Hi and welcome to the second video on quantitative marketing. The second video has the objective to explain the hypothesis test concept and also to show you how to use statistics to compare means of one variable in one sample or in two samples. So let's begin with the hypothesis test concept. The hypothesis test helps you to conclude if a relationship between two variables or if a difference between two groups is really significant using a statistic test that gives a probability. So first of all, when you would like to make a hypothesis test, the first step is to identify or to define two hypotheses for each test. The first hypothesis is called H0, and H0 always define the absence of the relationship between your variables that you would like to test, or the absence of the difference between groups that you would like to test. H1 is the opposite hypothesis, and H1 will allow you to test the existence of the relationship between the variable or the existence of the difference between groups. And when you put down these two contradictory hypotheses, you will test using a statistical test these two hypotheses, and you will, regarding the results of your test, accept the hypothesis 0 and reject hypothesis 1, which allow you to say, okay, there is no relationship or there is no difference, or depending on the statistical test result, you will reject H0 and accept H1. I will show you how to do this. Let's come back to the definition of hypothesis test. And we said that hypothesis test allow you to conclude if a relationship or a difference is really significant. What does mean really significant? Really significant means that this relationship or this difference that you will test and that you will observe in your sample means in the respondents that you ask. So are this relationship or are these difference can be generalizable to the entire population. So as you know, if you would like to test a difference between two groups, you cannot ask all the population. So you will sample a part of it and you will ask them and you will test this difference, but you need to know if this difference can be generalizable to all the population. The second point in hypothesis test is that you will use a statistic test. So what you need to know is that this statistic test depends on the type of the variable that you will test, and we can distinguish between several statistical tests depending if your variable is nominal or metric. This is why it's really important to identify if your variable are metrics or nominal or categorical. The result of the statistical test is a probability, and there is like a cutoff that should be respected. If this probability is lower than 5%, so you can conclude to the existence of the difference or to the existence of the relationship. In other words, if this probability is lower than 5%, you accept H1 and you reject H0, and you can say, okay, the groups are different if you are testing a difference, or the two variables are linked if you are testing a relationship. While if your probability, that is the result of the test, is higher than 5%, so you have more probability that the relationship will not exist. In this case, you accept H0 and you conclude to the absence of the difference or the absence of the relationship. Hypothesis test is an important concept, and it's a concept that is used for all the data analysis that you will do during this class. So let's begin with the first type of analysis, which is comparing means. So if you need to compare mean between or if you need to compare two means of one variable, so you will need a statistical test to be able to say if the two means are really different in all the population or not. So you here are faced with, in general, two cases. First case, you have your variable and you would like to compare the mean of this variable with the mean of the same variable but for the population. In this case, you have only one sample, that is the sample that you used, and you would like to compare the mean of this sample with what we call a theoretical mean. Let's imagine that you asked 100 persons in your questionnaire, and you would like to know if the mean age of this person respects the mean age of the population. Let's take the example of Facebook users. Okay, so you know that the mean age of Facebook user in the population, you know that this mean age is, let's say, 25 years old, and you would like to test if the mean age of your own population is statistically significantly different from the mean age of the population. In this case, you will use a t-test for one sample. While if you have this one variable, but you would like to test the mean of this variable between two different samples, in this case, you are faced to the case of a two-sample test. So, as I said before, you need to use the adequate statistical test depending on your objective and depending on the nature of your variable. You have to know that we already said that we cannot calculate mean for categorical variable or nominal variable. You can only calculate mean for metric variable. So you can only test difference between mean in case of metric variable. So you can be faced to three different cases. In the first case, one variable, one sample, and you would like to compare the mean of your variable with a theoretical mean or mean in the population. In this case, you will choose the one sample t-test. Other example, you have two samples or two subsamples, and you would like to compare the mean of one subsample with the mean of the other subsample. And here you have to distinguish if your two samples are independent or dependent. Independent mean that the two samples are not the same person. Let's imagine that you have the mean age of woman and mean age of man. You have these two samples and you would like to compare if the mean age of woman is the same as mean age of man. In this case, woman and man are two independent samples. While in some experimentation, you could ask some people to answer a questionnaire, and 3 months after you ask them, the same person, to answer another questionnaire. In this case, the same respondents will answer 2 times. And you have 2 samples, but in this case, there are what we call paired samples. For the same person, you have 2 measures. In this case, you will use a paired sample t-test. So I will give you example for all these cases, and we will begin with, you would like to compare mean of your sample, one variable in your sample, with what we call a theoretical value, or the value for all the population. So I will give you this first example. A researcher is planning a psychological intervention study. But before proceeding, he wants to characterize the participants' depression level. So the researchers test each participant on a particular depression index. So here the variable is the depression index, and as it's an index, we can imagine that here we are faced to a metric variable. And here, we know that every participant who achieves a score of 4 is deemed to have normal levels of depression. So 4 is the theoretical level for normal level of depression. Lower score indicates less depression, and higher scores indicate greater depression. So the objective of the researcher is to know whether his sample has normal levels of depression or abnormal, which is higher or lower score of depression. So first step here, we would like to compare means. We will test the hypothesis of the existence of a difference between the mean age of his sample and the mean age, the theoretical mean age, or the mean, we would like to compare the mean depression level of his sample and the mean depression level of the population, which is equal to 4. So to do this, the first step is to write the hypothesis. So, as I said it before, null hypothesis H0 is always absence of relationship or absence of difference. Here we would like to test if there is a difference in depression level between the sample and the population. So H0 means there is no difference in mean depression, while H1 means there is a difference in mean depression. So to test this null hypothesis, the researcher will recruit a random sample of 40 participants to take part in this study. Let me show you how it works on SPSS. So I will open my database, which is the answers of the 14 respondents here. You can see it on the depression score, and you can see that some people answered 3.6, other 4.2, etc. And our objective is to see if there is a difference between the mean depression scores of my respondents, my 40 participants to the study, and this theoretical depression score that means a normal depression level, which is 4. So first of all, let's look to the mean depression score without testing it. Just have a look about the mean depression score. So we already did it. Descriptive statistic, frequency, you choose the depression score, you go on statistics, and here you ask for the mean. Pursue, okay. Let me move this, okay. And you will have here the mean depression score of my 40 participants is 3.72. So is it really different from 4? Can we really conclude that they are not normally depressed, or it's quite close? It's not easy to answer this question, and hypothesis test will allow you to say if there is a statistical significant difference between this mean and the 4 level of depression. So to do this, you will go to Analyze, but this time you will choose Compare Means. And as we have only one sample and you would like to compare the mean of my variable in this sample to a theoretical mean, you choose t-test for one sample, for unique sample. So you choose t-test for unique sample. You ask for, in this case we have only one variable, so it's easier to identify which variable you put on the variable to be tested. But the important point here is to give the value of the comparison test. So I would like to compare the mean of depression score with a score of 4, which is the normal depression level score. So if I put OK here, we will see that the result of the test is this one. Okay? So we have the t-test value, and which is really important here is the level of significance. So this is the important result. The level of the value of significance is always written sig in SPSS or significance. So sig or significance is the famous probability that will allow us to have the result. Is there a difference or not? Remember that the cross point or the level that we need to know to conclude is 5%. If the result is lower than 5%, so we say, okay, there is a difference. If it's higher than 5%, we say there is no difference. In this case, the result of the probability test is 0.02, which is 2%, so it's lower than 5%. So we can say that there is a statistical difference between the mean age of my respondents and the mean age of the population. So we can say that my 40 participants are lower, have a low score of depression level, as the mean here is 3.7, that is lower than 4. So if we come back to our result, we can conclude that there is a difference in mean depression, and that my participants are less depressed than the mean or normal depression level. This was the example of the first case. One metric variable, you would like to compare the mean of this variable with a theoretical variable, so you apply the t-test for one sample. We have another possibility. So in the case you have two samples, and these two samples are independent. So in this case we will use independent t-test. I will give you an example. So let's imagine that an advertising agency is commissioned to create a TV advert to promote a new product. So since the product is designed for men and for women, so it's important that the TV advert equally touch men and women. So the TV advert has to appeal to men and women equally. So before the company that commissioned the advertising agency spends like more than $250, so across a number of TV networks, it wants to make sure that the TV advert created by the agency appeals equally to men and women. So the company wants to know whether the way that men and women engage with TV advert is the same. So we will compare the mean, like maybe likelihood of the advertising between men and women. So in this case, we have only one variable, that is the mean of likelihood, and we would like to compare it in two samples, men and women, but these two samples are independent. They are not the same person. In one sample we have men, and the other sample we have women. So first thing is to write down the hypothesis. My research question: is there a difference in engagement levels between the two independent groups, male and female? So hypothesis is always no difference, no relationship. So in this case, there is no difference in engagement level between the two groups, while hypothesis 1 say, okay, there is a difference in mean engagement. So to achieve this test, the TV advert is shown to 20 men and 20 women, who are then asked to fill in a questionnaire that measures their engagement with the advertising. And the questionnaire provides an overall engagement score. So here again, we have an engagement score, which is probably a metric variable. Okay. So once again, let's look how it works on SPSS. So I opened the database that corresponds to this example, and you can say here that we have, first of all, 40 respondents. We have the first column that indicate the gender. So you can see that the first 21 are men, while the second 20 are women. So to be sure that one is man and 2 is woman, you go to variable view and you have the value here of your answers, and you can say that 1 is male and 2 is female. Okay, let's come back to the data view. And you have here the score of engagement with the advertisement. And you would like to test if there is a difference between the two groups, male and females, in terms of engagement. So your variable that you will test is engagement. You will compare the mean engagement in two samples that are independent. So in this case, you choose Analyze, and you will compare me, but this time you will choose t-test for independent samples. So you have two cases here. First thing, you choose the variable that you will test, and in our case, I will test the engagement score. And then you need to know what are the two different groups that you will test. You have two samples. So what is the criteria that show you the two samples? So you will choose gender in the criteria, and you need to define the two groups. So you click on defining groups, and you say group 1 has the value 1 and group 2 has the value 2. In this case, we have two groups, so it's quite easy. But let's imagine that our criteria or our two samples are not distributed in terms of gender, but maybe in terms of age group. And in this case, you can have like 5 different groups, and you would like to compare the first with the fifth. It's possible. So this is why this step is important. So you click on OK, and we will try to find the result of the t-test. And you can see here. Okay, I will come back later. So you can see here that you have the t-test result. And the t-test result, you have to look for the significance level. And significance level is always here. And you compare to the 5% level. Lower than 5%, here it's the case 2.3%. In this case, there is no difference between the mean. So that means that women and men react in the same manner to the advertising. So the agency did a good work. So we can say, okay, there is no difference between men and women in terms of engagement score toward the advertising. Finally, we will see how to test a mean difference between two paired samples. As I already said, two paired samples mean that you have the same person that answers 2 times. So let me give you one example. In this example, a researcher wants to test a new formula for a sport drink that improves running performance. So instead of a regular carbohydrate-only drink, this new sports drink contains a new carbohydrate-protein mixture. So the researcher would like to know whether this new carbohydrate-protein drinks leads to a difference in performance compared to the carbohydrate-only sport drinks. So he will compare these two drinks. So to do this, the researcher recruited 20 participants who each performed 2 trials in which they had to run as far as possible in 2 hours on a treadmill. In one of the trials, they drank the carbohydrate-only drink, and in the other trial, the same persons drank the carbohydrate-protein drink. So, of course, to be sure that the order will not impact the results, so the order of the trials were counterbalanced. So that means that for some people, they begin with the carbohydrate-only drink, and then they drink the other one, and for other participants, it was the opposite. To do this, the research question is there a difference in the distance run between the 2 trials? And as always, the H0 say there is no difference between participant performance in the 2 trials, while the alternative hypothesis H1 say, okay, there is a difference between the performance depending on the drink that they drank. So let's open the database on SPSS, and I will show you how to test this difference. So in this case, So in this case, my database will show me that I have my participants, so my 20 participants here. And for each participant, I have 2 measures of the run distance, or distance that they run. In the first case, when they drink the carbohydrate, the carbo drink, and in the other one, carbo plus protein drink. Okay, and I would like to compare the mean of distance between these 2 trials. trials. So to do this, we go to Analyze, Compare Means, but this time we are faced to a paired sample, same people tested 2 times. So we choose Test T for paired sample, and here you need to create the pair. So I have only one pair, and this pair is a comparison between the carbo drink and the carboprotein drink. So he creates the first pair. I will not compare another pair, so I stop here. I simply click on OK. And I will look to the results. So the first table is just a descriptive table where he shows you that when they drink carbohydrate drinks, they run in average 11.60 maybe kilometers. While when they drink the carbohydrate protein drink, they run in average 11.3. So when you look at it, the two distances are really close. So it's difficult to say if this difference is significant. Can I say that this drink is better than the other one? So to do this, I will test it using a t-test. So this is the t-test result. And as always, you have to look for the significance level. You have the value of the t-test and you have the significance level here. And you can say that the level of the significance is 0%. So 0 is lower than 5%, which means that you say, okay, it's lower than 5%, I can accept H1, I can say there is a significant difference, and you can say that your carbohydrate protein drink improve significantly, not for a very high level, but it improves significantly the level or the performance of the runners. Okay, so just to conclude, what we seen on this session is first the hypothesis test concept, which is a really important concept in statistical analysis and which allow you to say if you can generalize your result to the entire population. And we applied this hypothesis test concept firstly to understand how to compare a mean between one variable in one sample or one variable into independent sample or dependent, or what we call paired samples. So thank you for your attention.